Section 6.8 is graphing radical functions. I can graph square roots and other radical functions. Big ideas for this section. A square root function is the inverse of a quadratic function that has a restricted domain. When you square each side of an equation, the resulting equation may have more solutions than the original equation. And if f and f inverse are functions, and if either maps a to b, then the other maps b to a. Inverses of power functions form parent functions for families of radical functions. A parent for the family of square root functions is f of x equals the square root of x. Members of this family have the form a times the square root of x minus h plus k. Very comparable here, guys, to what we did absolute values, when we did quadratics, when we did other polynomials, as far as our parent function goes. Stretch or compression, horizontal, and vertical changes. If you look at the take note on page 415, it talks about our families of radical functions here. So it has our parent functions for square root and then for any radical. Reflections in the x-axis means there's a negative out in front. Stretches, like I said, are the a values or compressions. And translations are horizontal, h units, vertical, k. Keep in mind, the difference between those is that the h is inside the absolute value, inside the radical, just like it used to be inside the absolute value bars or inside the parentheses before we took it to a power. Same idea here. And the k is after the fact. So in examples 1 and 2, we're just going to be translating a square root function. But before we can translate the square root function, we need to know what our parent function is here. So remember that the square root function is the inverse of a parabola. And we just want the positive part because we just have the positive square root, which means we only want the positive part of our parabola. So our inverse is going to be like this. Our points used to be for positive values. Our x values, we had 0, 1, 2. Our y values, then when we plug them in, 0 squared, 0, 1 squared, 1, 2 squared, 4. So for our inverse here, our square root function, we swap them. We change our x's and our y's. So we still have 0, 0, 1, 1, but instead of having 2, 4, we have 4, 2. And we're only dealing with the positive square root, so it's going to be just the positive values there. So my parent function for the square root is 0, 0, 1, 1, 4, 4. So instead of going 0 over 1 up 1 over 2 up 4, we go over 4 up 2. I put that in the wrong spot, sorry. 4, 2. Here we go. And this is our parent function. Square root of x. Now, our translations are going to be just like they have been all year long. Here, I have a minus 2. It's after my square root ends, so I shift everything down 2. Down 2, down 2, down 2. I go over 1, up 1, over 4, up 2, and connect them. And keep in mind, we only have arrows on the right side. We don't on the left side. We can't have negative x values there. Can't take square root of negative numbers. So it stops or starts right at 0 for our x's. Second one here, I have a plus 1. And again, it's after that absolute value ends. So here, I go up 1. So from my parent function, I go vertically 1, over 1, up 1, over 4, up 2, instead of over 2, up 4. And again, it's just in the one direction. Third one here, my plus 4 is inside. It's included, so it's a left and right here. I'm going to go left 4. I want my height, my y value to be 0, so I have to go for x to be -4. I'm going to go over 1, up 1, or I shift each point over 4. Over 4, up 2. Instead of 2 and 4, we go 4 and 2 because it's the inverse. And the last one here, the -1 is inside my square root. It's going to move me right 1. Because it's inside, it is a horizontal change. -1 means I'm going to go right 1. From my base point, I'm going to go over 1, up 1, over 4, up 2. And connect our dots. Kind of missed there, but general idea. So those are the differences that we have here from our parent function. Feel free to pause here and give these a try if you'd like. Now we're going to find the graphs of the following functions. Transformations here. This +2 is after my absolute value or my square root ends. So I'm going to go up 2. The -3 is inside my square root, so it's going to be a left and right. Since it's a minus, I go right 3. Here I have a -3, but it's after my square root ends. So I'm going to go down 3. Here I have a +2 inside my square root. So I'm going to go left 2. Those are my translations. But I still need to have my parent function so I know where to start. Again, this comes from the positive branch of a parabola, which used to be 0, 0, 1, 1, 2, 4. But because we have the inverse, the numbers that we used to plug in for our parabola are now our y's, and our outputs are now our x's. They switch places. Okay? So I have 0, 0, 1, 1, 4, 2. 0, 0, 1, 1, 4, 2. And keep in mind, again, when we draw this in, I can only draw in an arrow on one side and continue on one side. We can't have negative values that we plug in for x with our parent function. Here, I go up 2 for each point. Up 2. Up 2. I take each point and move it right 3. Missed there. Sorry. I take and I move down 3 each point. Or from our, kind of like our vertex, we can go over 1, up 1, over 4, up 2, instead of over 2, up 4, like a parabola. Again, it's the inverse, so we swap those values. And then left 2. 2, sorry. You do not need to draw in the parent function every time, but you certainly can. When you're doing these, I wouldn't do any more than probably 4 on a sticker. It gets to be kind of a mess here, especially if you're not changing colors. In example 3, we're going to graph a square root function. If we look here, we have a bit more going on. We're going to pick out what our translations and transformations are from our function first. So the negative is still going to reflect over the x-axis. The half, since it's multiplied in front, is still going to be a compression by a factor of a half. The -3 inside, actually we're just going to take the 3 there. So minus means right 3. The minus is part of our parent function. Remember, a square root of x minus h plus k. And the 1 at the end means we're going to go up 1. So Again, our parent function, 0, 0, 1, 1, 4, 2. From here, I'm going to go right 3, up 1, and that's going to be my base point, kind of like my vertex. Instead of going up, I'm going to go down because it's a reflection. And instead of going over 1, down 1, I'm going to go over 1, down a half. My height here is 1 times a half. Half. Instead of going over 4, up 2, I'm going to go over 4, down, because it's a reflection, 1. Because my height here is 2 times that compression factor, 1. So I'm only going to go down 1, and I can connect my dots. So same idea here as it's always been with absolute value, parabolas, polynomials, all the functions that we've done so far, cubics. Okay. Same idea. Pick out our translations: reflection, compression, horizontal, vertical. I did my horizontal and vertical first. I did my reflection, and then my stretch of compression. Same idea here. My parent function is just y equals the square root of x. My index is 2, so I'm going to use the square root. That parent function, 0, 0, 1, 1, 4, 2. And just like with our other functions that we've done, you don't have to draw in that parent function, but it might be easier to see it and remember if you do. The 3 is a stretch by a factor of 3. I'm going to go left 2, and I'm going to go down 4. And these are all my translations. So from my parent function, I'm going to go left 2 because of the plus 2. I'm going to go down 4 because of the minus 4 afterwards. And that's going to be my new base point. Instead of going over 1, up 1, like I did here, over 1, up 1, I'm going to take that 1 and multiply it by my stretch. I'm going to go over 1, up 3. Instead of going over 4, up 2, I'm going to multiply that 2 by my stretch of 3 and go over 4, up 6. And that is my point. So my new function looks kind of like that. And again, keep in mind, we only put arrows going towards the positive values because we don't want to have square root of a negative number. So here we just have a point, arrow going in just the one direction. And that's all I have for the first half of section 6.8.